like I said, we are a small startup. I'm the co-founder, as well as Patricia, who is here also. We are developing small-scale aquaponics for households. GreenFin Aquaponics is an AgroTech headquartered in Portugal, like you see here in the map, right beside the Spanish border. So, like a great businessman said in Portugal, we are not in the hand of Portugal, but in the middle of the Iberian Peninsula. So we we trade more with Spain than with Lisbon. So we are Europeans by no less. So we are originated from the Polytechnic Institute of Porto Alegre, and we do research and developing in circular aquaponic systems obtained through the integration of two distinct food productions, aquaculture and hydroponics. In a single circular system, aquaponics provides an integrated, sustainable, biological, ecological, and economic food production method for both consumer and production. How aquaponics works? Well, I guess someone here already know, but I'm going to try to explain a little bit for the persons who do not know. Aquaponics is based in a natural system that can found in every aquatic system. We use the fish as with both main goals. For one, for producing nutrients for the hydroponic systems, and also in some cases to provide animal protein for human consumption as an aquaculture production system. So it's a semi-closed system. So we introduce the fish for the fish that can only be, well, as we do it. We can only feed organic biological fish feed. So the fish the fish eats, converts that energy provided by the fish food as it grows, but also as the waste for feeding the bacterial system that is already in the system, and it's growing and provided the nutrients by the cycles, the cycle of nitrates to provide the nutrients for the vegetables to absorb. These vegetables are absorbing not only the nutrients mainly from the fish waste and the NO3s, NO2s, but also we can supplement some in some cases the lack of nutrients for some crops that we grow. That vegetables remove that waste from the water, and then provide the clean water for the fish to keep growing and keep providing that nutrients. So it's a semicircular, like I said, semicircular system. The method that we use, it's the simple one. There's another where we can separate the aquaculture system and the vegetable system, and for never touch each other. But we use the simple one, like you're going to see furthermore. Like I said, the main aquaponic systems that we have in the world, it's a normal greenhouse, normal hydroponic greenhouse, but with a small, bigger tanks. Not only a tank to provide the nutrients like hydroponics do, but a whole setup of tanks and to provide the better the space for the fish to grow and also the filtration to provide to convert those fish waste in nutrients. Here an example of the aquaculture tank. There can be from one tank to several tanks depending on the size of the greenhouse. The greenhouse. These can be measured not only as the full scale of the farm, but also as the times of the cycles of the plants. So it's not only have the tanks and fish, so the plants can grow, but we have to manage also the vegetable predation, so they can filtrate the water for that fish. So if we have a lot of fish and not enough plants, the system will crash. So if we have too much plants and not enough fish, the plants will not grow. So it's a little bit tricky to set up that fine method of fish of that ratio to fish to plants. So here I can present the aquaculture tank. In that case, we have a biomedia filter that can range from enormous of systems that can transform that fish waste into nutrients and is the base. So the main focus, the main part of the system is seen here. So the biologic matter can do its work and find to make the nutrients. The biofilter meter in the hydroponic media bed, they can provide not only the media filtration, but also the oxygenation for the system. So the plants need not only oxygen and CO2 in the root, in the leaves, but also oxygen in her roots, so they can absorb that nutrient. The hydroponic media bed can also provide some way of like in hydroponics to raise some vegetables. That vegetables can all be grown in a semi wet environment. Not as the deep water culture who can provide only the roots in water. So here I'm going to present a little bit of the difference between hydroponics in aquaponics in the base of what we understand. Hydroponics is a chemical nutrient based, organic or non-organic. In the aquaponics, we can only use organic matter, so the fish will not die. So as long as the fish is well, the system is also well. So we can only provide organic and natural nutrients to the system as well as the feed. In hydroponics, the bacterial growth is inhibited. In aquaponics, we use mainly bacterial systems, so we can have the transformation of fish waste in nutrient. In hydroponics, as less cost effective. In aquaponics, it's more cost effective because in this case like the next point, the system should be unloaded after a certain period because of the buildup of slats and toxic chemicals in the aquaponics. We don't waste any water. The water stays all the time. We only do tap off. We only provide another quantity of water because the plants use them, and of course the evaporation of the system. So we do not waste any water. The water, once in the system, stays in the system. We don't exclude any water because of sleds or toxic chemicals that is going to be in the system. In hydroponics, as our point of view, it's difficult to maintain because it is a balance between the nutrients that the plants get and the nutrients that we have in the system. So hydroponics is a bit like some people need to be chemists and not and do a balance between what is in the system, checking all the time. In aquaponics, it's immediately difficult. We have to know a lot of chemicals too, a lot of biological because of the fish. Also, but it's a natural system, so the system will provide as long as we feed the fish, the system and its balance, the system will provide the nutrients for the plants to grow, and the plants will provide the clean water for the fish. So it's a more balanced system than the hydroponics one. In hydroponics, the market is established. Everyone nowadays eats, if you know or not, hydroponic food. Aquaponics is a growing market, but it's also a niche market. Not everyone, like I said before, not everyone knows aquaponics, and it's still a bit an underdog, as we like to say, because it's a difficult method to put in the head of the person that we don't use fish waste to grow the plants. We will use the nutrients that the fish waste provide, so we can grow our plants as the same as we provide animal base to our soil. We provide fish waste to our plants. Well, in hydroponics, it's well funded. EU as to a lot of grants and funders to start the greenhouses and provide the hydroponics for market consumption. In aquaponics, like I'm going to provide again in the next slide, it's difficult to fund because hydroponics, aquaponics, I mean, aquaponics, it's for EU or the general public is hydroponics, it's aquaponics, it's industrial aquaculture, it's wastewater recycling, it's urban aquaculture. It's not well orientated in terms of EU regulatory framework, because we don't know exactly which category aquaponics is set up. So we don't have a policy recommendations for the states, for the EU states. So probably in Portugal can be done. In Spain cannot be done. In Germany there are building constructions laws that are not in Portugal. So it's not a regulatory framework for all EU states. And the most of all, besides, we are a system that mainly is organic and natural. EU organic regulations do not provide aquaponics as a certified organic food system. So it's very difficult to obtain the organic classification for a natural system who can only use organic and natural methods for it to grow. So it's a little bit constrained that what we have, and that this results in no funds for this, because if we have funds for the hydroponic part of the system, we cannot have for the same system funds from EU for the aquaculture side. I mean, we cannot have funds for the global of the system. We can only have for the aquaculture part or for the hydroponic part, and this it's a little bit more difficult because it's two different sides of the express. One is ocean or aquaculture or fishing, and the other is agriculture, like the hydroponic part is agriculture. So there are two different constraints in both sides that is not measured in just one, so we can provide. So it's a little bit difficult. In this case, because the difficult, we change our perspective of way for a small scale aquaponics for our household. We provide indoor and outdoor small scale aquaponics for the people to have in their house. One for in a little kitchen, so it's patent pending right now. We are in the process of patenting the system, the indoor system. So we can all have a little bit of an aquaponic system in our kitchen, so we can provide fresh and healthy aromatic herbs for our kitchen. We also have an outdoor. In this case, an outdoor. We here is one customer we have in the small garden, but we also have this in a balcony. So, and we provided the small outdoor system with a grown area and optimize the space, so the people can have not only the base system, but also a more lucrative part of the system, and grow vegetables and lettuce, and besides it's a design piece, so we can have. We also provide for a customer small planters. It's all connected to this area where the fish have, and below the surface of the deck. It's where the main lines for the system to grow in the grow beds. We here are we presented some fairs and explain our systems for in the number of bases. Here are another example. Here we have the system that we put in the local institute, the Polytechnic Institute. It's there in their lake. Their lake it's there with fish. It's always green. And now, as we put the system, the system don't need to change the water so much, and and this provide not only some vegetables, but also some flowers for them to have a nice place, and they provided some information for our market, and the way that we can extract some market statistics and some market point of views from the students in the institute. Well, thank you for your attention.